All right, I want to find the area between two curves. So let's draw the graph of two different functions. Let's work on f of x first. It's a straight line with a slope of 1/2 with a y-intercept of 3. So I'm going to cross right there. And what's going to make that 0? Where do I cross my x-axis? If x was -6, then -6 divided by 2 is -3. -3 plus 3 is 0. So, oh, it's off the page. Well, let's give ourselves the furthest to the left that we can go. If you plug in a -3 here, you get -3 over 2 plus 3. Let's write that as 6 over 2. That gives us a 3 over 2 or a 1.5. So we're at 1.5. We're right there. All right. And this was f of x. Cool. Let's graph g of x. Minus x squared. So it's x squared, except it's minus x squared shifted up by 1. So y-intercept of 1. And where are my zeros? If x is equal to plus or minus 1. It's going to look something like this. All right, again, bad at art, but we just need the idea. And we want to find the area between these two functions between x is equal to -2. So there's x is equal to -2. Right? It'll eventually run into our function. And x is equal to 1. So I'm looking for this area. And I can find that area by integrating the difference of these two functions. So I want to integrate as x travels from -2 all the way to 1 of which is the top function. That's f of x. And then the bottom function here is g of x. Right, so f of x minus g of x gives me this distance, right? The distance between these two functions. So the idea here is we take this difference and then we integrate it, or we add all of these distances up, and that gives us an area. Okay, so let's just go through this. This is the integral from -2 to 1. F of x is 1/2 x plus 3. I need to subtract g of x. All right, so remember, wrap g of x in parentheses because you want to subtract off the entire g of x. Let's simplify the function first before we find an antiderivative. This will be 1/2 x plus 3 plus an x squared minus a 1. So we can combine that plus 3 and minus 1. We end up with x squared plus a 1/2 x plus 2. And I can find that area or that definite integral by finding an antiderivative and evaluating the difference. So this will be 1/3 x cubed plus, what is that, 1/4 x squared plus 2x evaluated between -2 and 1. So if you plug a 1 into this, you get a 1/3. Let me write it out. A 1/3 plus a 1/4 plus a 2. And if you plug a -2 into this, you get a -8/3 plus a, what, 2 squared is 4, but 4 over 4 is 1. So you get something like that. And when the algebra clears the room, you get 8.25. So that's how much area is between those two curves.